When the second derivative is zero, why can we not classify a critical point as a min or a max? Let's take a look. When our derivative is zero at a, that means we're a critical point. When the second derivative is positive, that means our derivative is increasing. In other words, the mini slopes of f are increasing. So when you draw those mini slopes as getting bigger, going from negative slopes to zero slopes to positive slopes, if we know that f prime is zero, then clearly we're going to be a minimum there. When f prime is zero but f double prime is negative, our mini slopes are decreasing. So when you graph f, your slopes are getting smaller. And then clearly, if the derivative is zero, you're going to be a maximum. But what happens when the second derivative is zero? Well, it could be that our function is changing its concavity. So you could be concave down and then change your concavity at the exact same point where your derivative is zero, in which case you would be neither a min or a max. But just because your second derivative is zero doesn't mean your second derivative changes sign. You could be having a function where your second derivative is positive, meaning you're concave up. It becomes zero for a second, so it's thinking about becoming concave down, but then it's like, no, I'm going to stay concave up, in which case, when your first derivative was zero, you were still a minimum. Or conversely, if you were concave down, you stop for a second thinking maybe my function will become concave up, and it's like, nah, I'm going to stay concave down, you would actually still be a maximum. So the test in this case is inconclusive. So when your second derivative is zero, your function could have a minimum, it could have a maximum, or it could have neither. So that's why when your second derivative is zero, our test is inconclusive. Hope this helps.